Let's do a limiting reagent problem together. Now, a lot of people hear the term limiting reagent and like, ah, but really limiting reagents are a fun way of just testing your chemistry knowledge and saying, hey, I want to walk in the lab and I want to use up all the stuff I got. So if I've got all of compound A and all of compound B and I mix them together and I create some really cool compound, how much of the compound is created? Well, it's going to depend on my starting materials. If I have a whole lot of A and hardly any of B, then B is going to limit how much of my product I can make. But if I have a whole lot of B and not a lot of A, you see where I'm going with this. So the amount of product that you can create in the laboratory is depending on your starting materials. So can I measure out both compounds, go in the lab and predict how much I should potentially be able to create? Absolutely. And that's the idea behind theoretical yield. And so in today's video, we're going to walk through step by step how to calculate a theoretical yield for a problem. But why this is pretty fun is you get to remember everything you've learned so far in this class. So we're going to practice working with ionic compounds, naming, calculating molecular weight, and then a whole bunch of conversions. And that's the basis behind a limiting reagent problem. So for our problem, we're going to work with the equation that you see right here. So the idea is we have barium chloride plus sodium sulfate to yield barium sulfate plus sodium chloride. So if that is our equation, we need to figure out what does it look like, what does the balanced chemical equation look like. So to begin with, we've got barium and chlorine and sodium and sulfate. Now, I purposely did not put any of the charges on there because I want you to go look at your periodic table, pause the video, and practice putting your charges on each of these compounds. What you should have done is barium is 2 plus, chlorine is negative, sodium is positive, sulfate's 2 negative. Now, in our reaction, we're reacting barium and chlorine together, which means you take your charges and you cross them. So it becomes BaCl2 plus cross these charges. That becomes sodium sulfate. Okay, because your 1 comes down here to sulfate, your 2 comes down here for sodium. Then for our products, it's actually what's called a double displacement reaction, meaning barium is now an ion in your solution or in your mixture, and so what you've got is barium can find chlorine because opposites attract, or it can disassociate from the chlorine and go find the other negative in your compound, which is, or in your reaction, which is sulfate. And then same thing for sodium and chlorine. They can find each other because opposites attract. And so you're going to do that same crossing of charges now in our products to form barium sulfate. Cross those charges, the 2's will balance each other out to give you with 1 because you want to go with your lowest common number, plus Na and Cl. Now, I'm not going to write it as ClNa, remember, because your cation is always written first. So sodium chloride. Now, it doesn't matter if I wrote barium or this one first. They can be moved around, and these 2 can be moved around. But this needs to be on the left side of the arrow, and this one needs to be on the right side of the arrow. I just separated it because we're in a video, okay? And so sometimes it's a little bit trickier to run out of space going that way. But they should all be in a line. And now we need to balance this because we're not done yet. We got to figure out what do we need to do to balance. I hope you see that there's 2 sodiums here, so you're going to need 2 sodiums there. So now if we check, we have 1 barium on each side, 2 chlorines on each side, 2 sodiums on each side, and 1 sulfate on each side. Now this is our final balanced chemical equation. What I want you to do now is I want you to calculate the molecular weight of every single molecule within our chemical equation, because we're going to use that for our next step, which is converting from one compound to the next. So pause your video and do that right now. Check your work and see if you got the following molecular weights. You should have gotten barium chloride is 208.23 grams per mole, sodium sulfate is 142.041 grams per mole, barium sulfate is 233.391 grams per mole, and the last one, sodium chloride, is 58.443 grams per mole. You do need that unit on there. Now, the main thing is you might be off by like those last couple decimals. That's okay. Check your work, make sure you're pretty much the exact as what you see on the screen. All right, now let's go into our limiting reagent problem. If we've got our balanced chemical equation, which you see up there, then you're told the following information. You're starting out with 1.40 grams of barium chloride, and we're reacting it with 1.20 grams of sodium sulfate. If you are given this information and asked, what is the theoretical yield of our experiment? So theoretical yield, and notice whenever you say theoretical yield, you typically mean with grams. You don't typically say, oh, I made this many moles. It's, I created this many grams of my product, or this many milliliters of my product. So it's normally grams, but it could also be milliliters. What is the theoretical yield? Let's just choose, for kicks and giggles, let's choose sodium chloride. So meaning, if I start out with 1.40 grams of barium chloride and I react it with 1.20 grams of sodium sulfate, how much sodium chloride am I going to produce based on that balanced chemical equation? So this problem, what it's asking you to do is think about the idea that you've got two entities. Now, even if they're one-to-one in the chemical equation, that's one-to-one moles, not one-to-one mass, which means you don't know if you have fewer number of molecules of this or fewer number of molecules of this. You don't know if you have fewer number of moles or fewer number of moles. But what you can do is you can use molar conversions to figure out which one is going to limit your reaction. So we're trying to figure out a theoretical yield. In the past, you might have said, react barium chloride with as much sodium sulfate as you want. That's like excess sodium sulfate. Or you could have done the opposite, react sodium sulfate with excess barium chloride. Those aren't limiting reagent problems. That's where we're simplifying the problem to make it easy for you, just throwing a whole bunch extra. This does happen in real life. Because if you're going into a lab and you know that one of your reactants is really expensive and the other one is dirt cheap, you know what you're going to do? You're going to use the exact amount of the expensive compound that you need and just throw in as much extra of the other one as you might need, just to make sure that you're wasting the cheap product and you're saving money or using only the expensive amount that you need. All right, so that's this type of problem. You can do it all in theory before you sit down in lab and start reacting stuff. Okay? So what we're trying to do is figuring out which one, according to these ratios, which one is limiting our reaction and which one is in excess. Now once again, just remember, just because this number is bigger does not mean it's going to be extra. And just because this is smaller does not mean it's limiting, because it's based on both your molar masses and the balanced chemical equation. Both components are part of this vital answer. Okay, so let's calculate this problem. What I do sometimes is just take both of my compounds and convert it into sodium chloride, because if we just go all the way to sodium chloride, we can just look at the question and be like, well, that one's going to produce this much sodium chloride and this one's going to produce this much. Which one's smaller? Okay, so that's my strategy that I'm going to employ in this video. So let's start out first with 1.40 grams of barium chloride. I need to convert that all the way to grams of sodium chloride. So how do I do that? Grams of barium chloride to moles of barium chloride. Now I convert moles of barium chloride to moles of NaCl, and then moles of NaCl to grams of NaCl. And you should have known how to do this already. Okay, and we'll put the answer right down here. So in this case, we've got our molecular weight in the first one. So let's write down our molecular weight of barium chloride, 208.23 in 1 mole. Remember, molecular weights are always in 1 mole. Now this is our balanced chemical equation. So in this reaction, we have sodium chloride had a 2 in front of it, barium chloride had a 1. And then in 1 mole of NaCl, our molecular weight is 58.443. And if we do all of that math, come up with our final answer, we get 0.786 grams of sodium chloride. So that is not yet our theoretical yield. That's if you throw 1.40 grams of barium chloride into a excess and combine it with an excess amount of sodium sulfate, that's how much we would produce. But we have an amount of sodium sulfate too. Do we have enough for all of my barium chloride to react? If we do, then this is my limiting reagent. If we don't, then it's excess. We'll talk about that more once we calculate. So 1.2 grams, let's do this conversion next. 1.20 grams of sodium sulfate. Let's convert it the same way to grams of sodium chloride. So sodium sulfate is 1 mole sodium sulfate, has a mass of 142.041 grams of sodium sulfate times my molar conversion, so 1 mole of sodium sulfate to sodium chloride, 2 moles of sodium chloride. And then we have over here 1 mole of sodium chloride, and that has a mass of 58.443 grams. For a total, if you multiply all that together, for a total of 0.987 grams of NaCl. We have converted each of our starting reagents into final finished product. So we've got both of these, and just remember, reagent, reactant, they're kind of the same thing. They just mean this is on the left side of the arrow, and my product is on the right. So 1.40 would have produced 0.786 grams, while 1.20 would have produced 0.98, which means this one is my excess reagent. Sometimes I will call that ER for short. And this one is my limiting reagent. Barium chloride is my limiting part of this reaction. So I'm going to call that LR. Now notice, limiting reagent and excess reagent always just reply to reactants, not to products. Okay? The product is my theoretical yield. So this theoretical yield, this is my final theoretical yield. If I combine these two amounts, will I ever create 0.987 grams? Absolutely not. Okay? And oftentimes I would recommend putting an X through it. Remember that you're not going to create that amount because you don't have enough barium chloride. Because remember, for every 1 mole of this, you need 1 mole of this, and we just don't have enough. We don't have enough that we can measure out and put on a balance. All right? So that's how you run a limiting reagent problem. So if I were to ask, what is the theoretical yield of sodium chloride? My answer would be 0.786 grams of sodium chloride. And if I were to ask, what's the limiting reagent? Barium chloride. What's the excess reagent? Sodium sulfate. Let's do the exact same problem, except for instead of grams of sodium chloride, let's calculate grams of barium sulfate. So notice this will be the same idea, but now we're going to just start here because we don't need our excess reagent. We know this is going to produce the smallest amount of barium sulfate. So we can essentially just start right here and make our conversion that way. So I'm going to pause the video. You try it. Convert 1.40 grams of barium chloride to grams of barium sulfate. All right, so you should have started here where you've got grams of barium chloride converted to moles of barium chloride. Now use your balanced chemical equation. 1 mole of barium chloride per every 1 mole of barium sulfate. And then convert moles of barium sulfate into grams of barium sulfate using our molecular weight of barium sulfate. Okay? And so we end up at the end with 1.57 grams of barium sulfate. All right, so what you should remember is that when you're going from grams, you've got grams to moles, molecular weight, moles to moles, balanced chemical equation coefficients, moles to grams, molecular weight, to give us a final amount. This here is our theoretical yield of barium sulfate. And this, in a nutshell, is our theoretical yield problems. It's our limiting reagent problems. It's just when you have two different amounts of starting material, you're going to have to figure out which one is going to limit the reaction. And that is a limiting reagent problem.